Hey guys, so let's discuss round 6, which is low level design. Okay, so here in this round, you have to design a e-commerce shopping cart. So here we will be discussing about class diagram, their relationships, okay, and then database schema, APIs, and then after that we will be talking about around 14 follow-up questions. Okay, we will be seeing answer for 3 roles. The first one is software engineer, then senior software engineer, and architect level. Okay, so now let's start. So see, design an e-commerce shopping cart. Okay, so this is one of the most frequently asked Amazon interview question. Okay, low level design interview question. So this is most frequently asked, and questions for senior software engineer, principal engineer, architect interview. So now, unlike system design, here is the interviewer wanted to evaluate. What he wanted to evaluate, the object-oriented design. Okay, here we will be talking about the design pattern, what we are gonna use, and then after that, solid principle, design pattern, extensibility. Okay, if you wanted to add new feature in future, then how you will extend your application there. Okay, and then maintainability, clean API, thread safety, and business logic. So now again, the expectation changes based on the experience. So if you are a software engineer, then you need to focus on creating clean classes with proper relationship in the sense inheritance, composition, etc. Okay, the design should be easy to understand. Okay, and work correctly. And if you're a senior software engineer, then in that case, design should be ready for production. Okay, easy to extend with new feature, and handle multiple user and thread safety, concurrency. So concurrency, extensibility, all those things you need to take care. Now if you are a principal architect, okay, principal software engineer or an architect, then you need to design large scale system with clear business domains. Okay, it should be domain driven solution, and then event driven communication between services. Okay, and high scalability and long term maintainability. So now let's see what 3 to 6 years of experience software engineer would answer for this. So he would be answering that before designing the shopping cart, okay, I would clarify a few requirements. So what is the question? They will say that design an e-commerce shopping cart. So he will first ask a few, means he will clarify a few doubts. Okay, few requirements. So should user be able to add, update, and remove product, okay, from the cart? Then do we support guest users? Okay, after that, should price be recalculated automatically? So let's say I have added a product in my cart, and after some time, okay, let's say the price changes, so it should recalculate again, right? And then can coupons applied, because it is a e-shopping cart, so definitely people will use lots of coupons there. And then do we reserve inventory immediately or only during checkout? Because the problem, immediately, if you during checkout, if you reserve it, then in that case, might be between that time someone else has added that into their cart, or proceed for the payment, right? So that question he will ask. Now, I'll assume a shopping cart that supports authenticated and guest user coupon price calculation and checkout. Okay, so this is what his assumption. Now here you can see the class diagram. Okay, so we will have one user class which will have user ID, name, and email as attribute. Then you will have shopping cart. Okay, so you can see here one-on-one relationship. So we will talk about relationships also here. Okay, so you can see here one-on-one relationship, then you can see here diamond symbol, then you can see here empty diamond symbol. Okay, here you can see this dependency dash arrow. Okay, so you can see here we have few classes like user, then shopping cart. So inside shopping cart, what you will have, cart ID. Okay, one user will have one shopping cart. That's why one-to-one relationship. So you will have inside that shopping cart, cart ID, user ID, then list of items, okay, of type cart item. Now coupon and total amount. Okay, then you will have few APIs, right? Like add item, remove item, update quantity, or checkout. You will have one coupon class. Okay, so in coupon you have a code and discount, and then validate method, okay, which will validate the coupon with whether it is still valid or not. Then you will have a cart item. In cart item you will have product, and it's a quantity and price, and then you will have a product. So product ID, name, price, and stock. Now let's see what are these relationships. Okay, So here, this class diagram uses different types of UML relationships. Okay, so we have seen different UML relationships here. Here is a simple example of each other. Okay, the first one is user and shopping cart. So this is association. Okay, one-on-one. So you can see here that what is the meaning of association here. Okay, and one-to-one. So its meaning is one user has exactly one shopping cart and one shopping cart belongs to one user only, always. Okay, and example, user Chetna owns cart 123. Now second is shopping cart and cart item. Okay, so this is composition, and here you can see one ratio one dot 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 star means many. Okay, one to many. So it means that one shopping cart can have multiple cart items, right? So shopping cart and then this diamond symbol, okay, and then cart item. So one and one to many. So field diamond. Okay, so this is called the field diamond, shopping cart and cart item. So here you can see, let me remove this. Yeah, so here you have this shopping cart, okay, this one, and then cart item means this one. So here you have a field diamond and this is empty diamond, okay, and then one to many relationship, and here you have one and then 0 dot dot 1. Just see the difference. Okay, so 0 dot dot 1 matlab means either you will have a coupon, okay, or you will not have a coupon. Okay, either 0 or 1, that's it. But here 1 dot 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 star means you can have one cart item or you can have many cart item. Okay, but shopping cart will always be one. And here empty diamond symbol and filled diamond symbol means see what is the meaning of that, we'll see here. Okay, filled diamond means composition. Okay, so meaning a shopping cart is made up of one or more cart items. Okay, if the cart is deleted, all its cart items are also deleted. So composition, if you remove these cart items, so that there will be no use. Okay, so example, cart 123 contains iPhone, 2 iPhones and 1 laptop. Now shopping cart and coupon, so that is the empty diamond. Okay, so here you have this empty diamond. So what is the meaning of this empty diamond? See, empty diamond means aggregation. Okay, so filled diamond means composition, empty diamond means aggregation, meaning a cart may or may not have a coupon. So the coupon exists independently to the cart. Example, coupon CF20 can exist even if no cart is using it. Okay, so you understood the difference. Composition means the shopping cart made of this cart items, and empty symbol, empty diamond means may or may not have. Okay, aggregation. So now 0 dot 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 1 means 0 means no coupon applied, 1 means at most 1 applied. Okay, now cart item and product. Okay, so the relationship you can see association 1 and 1 star. So it means that in one cart item you can have multiple products. Okay, so meaning every cart item refers to exactly one product, and the same product can appear many cart items, different users cart. Okay, so that item can have in different users cart also. So that's why 1 star. User A's cart have the iPhone, user B's cart have the iPhone. So both cart items point to the same product. Now shopping cart and product relationship would be, it is a dot 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 arrow, okay, which is a dependency. So it means that dashed arrow means dependency. Okay, so meaning shopping cart uses product temporarily but doesn't own it. Okay, so method like add item, and so in item you will have a product. Okay, and then product quantity, how many items you have to add of that product, depends on the product class. Example, when adding an item, shopping cart reads the product's price and stock. So now this was about the relationship. Now let's see the summary table, okay, for this relationship, which will have the association, composition, dependency, aggregation. So user and shopping cart. Okay, so it is a association symbol, association relationship there. Okay, means user own one cart, one user, one shopping cart. Now shopping cart and cart item, so if you delete the cart, item will also be deleted, right? So this is composition. So cart contains item, item die with cart. Shopping cart coupon, so this is aggregation. It means that cart can use a coupon or coupon exist independently. Okay, now cart product and cart item and product. Okay, so in so this is so association again there. Okay, cart items reference one product, so cart item equal to iPhone. Now shopping cart and product, so dependency. Okay, cart temporarily uses product method like add item. So easy way to remember is association means knows about, user has a cart, okay, has a relationship, and composition is part of, cart owns cart item, so here owning part comes. Aggregation, so has a built and existing separately, okay, cart has coupon, and then dependency, so uses temporarily, so shopping cart uses product in method. So this is this kind of dependency you have to explain there in the class diagram. You can create anything by your own, okay, whatever you think is required there. Main API you will be using here: add item, remove item, update quantity, apply coupon, and get total and checkout. Okay, these are the main APIs. Now, what senior software engineer who has 7 to 12 years of experience would answer for this? Instead of placing all business logic inside shopping cart class, okay, I would separate responsibilities into services following solid principle. This improves maintainability, testability, and scalability. So he will break this business logic into multiple services. Okay, now architecture will be something like this. First you will have a shopping cart controller, then you will have a shopping cart service, okay, and then this service will collaborate with different services. For example, coupon service, inventory service, pricing service, payment service, and then wishlist service. Okay, and then if you talk about here the API, so shopping cart service will have add item, remove item, update quantity. Okay, pricing service will calculate tax, discount, okay, shipping, and then promotions. Every service will have its own responsibilities or its own area. Okay, inventory service, so it will first validate the stock and then reserve inventory. Now coupon service, it will first validate the coupon and then calculate the discounts. Okay, now payment service will do checkout thing and then payment part. So what is the advantage of making multiple services here? So first of all, it is loosely coupled, okay, loose coupling. Then loose coupling means you can make any changes to any service, okay, it will not affect your entire system. You can deploy it independently also, okay, and then tomorrow if you need to use different logic, you can just use that, you plug that new service, okay, to the system. Now easy testing, easy extension, and microservice friendly. What principal engineer would say here? So expected answer would be, at enterprise scale, the shopping cart becomes part of larger e-commerce platform. I would separate the cart domain from inventory, pricing, promotions, payment, and order domain using domain driven design, okay, domain driven design, and event driven communication. So here he is talking about asynchronous communication and then domain DDT. Okay, now enterprise architecture, if you see here, so see, first request will come to API gateway, then from there to shopping cart services. Now shopping cart services will talk to different services, right? We have seen that inventory service, pricing, promotion, payment, and then recommendation. And then using Kafka event, okay, it will call asynchronously your notification service, your order service, your analytics, these things. So design goal, what design goal would be here? High availability, stateless service. Okay, stateless service we have seen in the earlier video, where you don't need to maintain the state. Okay, every request will have its own whatever that request requires, it will have everything, okay, like a bearer token and everything for the authentication. Now event driven communication, horizontal scalability, independent deployment, loose coupling, and then eventual consistent workflows. Okay, so now let's talk about follow-up questions. So we will be talking here 14 follow-up questions. Okay, so the first one is coupon engine. So how you will design a coupon engine? So a software engineer will say coupon should be validated before checkout. Okay, that is correct. So like for example, if user has applied save 20, so first it will check what are the minimum purchases required, okay, to apply this coupon. Then it will check whether it is expired, not expired, okay, and then it will validate the user also, okay, after coupon, and then he will apply the discount. What senior software engineer will say here, I would implement a strategy pattern where each coupon type has its own implementation. Now here he will in the coupon engine he will apply the strategy pattern, okay, different strategy. So for example, first you will have an interface which is called coupon strategy, okay, and this interface will have a method apply method, okay, which will take a cart item and return the double, okay, so discount, how much discount he got. So for example, this is your interface, okay, coupon strategy, and let's say you have one class which is a percentage coupon which is implementing this coupon strategy, okay, so it will override its apply method. Now second, you might have a different type of coupon also, let's say flat coupon, okay, so flat coupon will directly negate some value in the from the total item, right? So again coupon strategy will implement, and it will, so flat coupon will implement coupon strategy and then override the supply method. Similarly buy one get one, okay, so you will have here buy one get one logic, and then it will return something. So he will have different strategies, okay, and on dynamically he will apply that. So for example, coupon strategy reference he has created, okay, and then he is creating object of percentage coupon, okay, and then he will call the apply method. So this percentage coupon logic will get applied. So strategy pattern he will be using. Why use a strategy pattern? So software engineer will say that different coupon logic is separated into different classes, which is correct. Now senior software engineer will say add a new coupon by creating a new class, okay, no changes to existing class, open closed principle, okay, solid principle, open closed. So tomorrow if new strategy came, you just create one class, okay, and just create object of that class. So this will be a loosely coupled, and principal architect will say that coupon strategies can even be loaded dynamically from configuration and different services, making the system highly extensible. Okay, so what principal software engineer wanted to make it more business friendly, okay, so you can load these coupon strategy dynamically, let's say rule engine, okay, in database you will change, so you don't need to ask developer to change the code every time, okay. So that is what principal or architect is saying. Now architect will say that coupon rules should be externalized into a rule engine. See here he is talking about rule engine, okay. So business teams can introduce new promotions without changing application code, which is correct. So instead of hard coding coupon logic in Java classes, store promotion rules into the rule engine or configuration. This lets the business marketing team creates, modify, remove coupons without asking developer to change the code and redeploy the application. So for example, if you hard code the value there, so Java code, so code would be written something like this: coupon dot equals save 10, so give the 10% discount, but that is incorrect, right? If marketing wants save 20, then a developer must update the code and deploy again in this case, okay. Now what he will do, so if you have worked on rule engine, so we add rules in a database, and then on run it will directly read from the database, okay, and then replace these variable value there, okay, read it from database. So for example, rule you will create something like this: if cart amount is greater than 1000, then give 20% discount, okay, or if user is premium and buy 2 shoes, then give 500 rupees off, okay. So the application simply asks the rule engine, okay, so rule engine dot calculate discount, okay, and then it will just calculate the discount for you. Now the business team can add new promotion through an admin panel or configuration without any code changes. Architect's goal: separate business rule from application code, making the system flexible, scalable, and easy to maintain. Now follow-up question 2 would be related to inventory reservation, okay, when you need to reserve the inventory, okay, at the time of whenever you are adding item in a cart, that time, or at the time of checkout, okay. So software engineer will say that before checkout verify stock availability, okay. Now senior software engineer will say reserve inventory temporarily, after checkout starts and release it automatically if payment fails or timeout, okay. So you reserve when for temporary, for some time, just reserve it, okay, and then when user is checking out, so that time if anything fails, payment fail or something, timeout or something happens, so just release it, okay. Now architect is saying that inventory reservation should be handled by inventory service using distributed transaction or saga pattern instead of shopping cart service, okay. So here he will connect to different services, and then multiple services will be involved to complete this transaction, okay. So for example, see, we will see the example. The shopping cart service should be manage the cart. Okay, shopping cart is associated to management of the cart, and when a user checks out, the inventory service, okay, is responsible for reserving stock. If multiple services are involved like inventory, payment or order, use a saga pattern to keep everything consistent if one step fails. Okay, for example, user clicks on checkout, let's say. Okay, so shopping cart service, he will create a checkout request, and then inventory service reserved to iPhones. Payment service will charge the customer, okay, and order service will create the order. So if payment fails, okay, here if payment fails, the saga trigger the compensate action. Compensate action means a refund or something like that. Okay, inventory service release the reserved to iPhones. Why? See, shopping cart service only manages cart item. Inventory service owns the stock and reservation logic. Saga pattern ensures consistency across multiple services without using one large distributed database transaction. Okay, so now follow-up question 3 would be related to wish list. Okay, so now wish list. So software engineer will say wish list, the store product the customer want to purchase later, right? Senior software engineer will say that wish list service be an independent service because it has different life cycle from the shopping cart. Shopping cart life cycle is different, and wish list life cycle is different. Now what architect will say about wish list, right? So he will be thinking broader. So wish list event can be feed to recommendation engine and marketing campaign. So he's talking about that we can use this wish list for recommendation engine, and we will recommend this kind of product to user next time, because we know that he is interested into that product, that's why. So now follow up 4 is guest cart. Okay, so guest cart means let's say I don't want to log in, I'm just browsing, and then I have added something to cart. Okay, so guest cart, software engineer will say that store guest cart using a session ID or browser cookie. Okay, fair enough. Now what senior software engineer will say that persist guest cart in Redis with the expiration time. Okay, Redis with TTL. Now architect will say that support seamless migration from guest to authenticated user during login. Let's say I wanted to purchase this, okay, so I will log in it. Now whatever was in my wish list or in my guest cart will convert it into my account's or shopping cart. Okay, I don't need to again add it into the cart, it will automatically come there. So meaning when a guest user log in, okay, or create account, their existing data such as shopping cart, wish list or preferences should automatically transfer to their authenticated account without losing anything, right? So good customer experience. So now example, user add 3 items to the cart as guest, user logs in, those 3 items are merged into the user's account cart, the user continues shopping without starting over. Okay, so now follow 5 will be related to merge cart. Okay, so now you need to merge the cards. See, when a software engineer will say that when a guest logs in, merge guest items with the user's existing cart. Okay, that is correct. Senior software engineer will say that he will use the rule like sum quantities, okay, and then remove duplicates, validate stock, and then recalculate prices. Now what architect will say, the merge operation should be idempotent, so retries don't duplicate the item. Okay, now follow-up 6 will be related to price update. Okay, let's say price will get updated after some time. Software engineer will say always recalculate price during checkout. Okay, senior software engineer will say that listen to the product price update events and refresh active carts asynchronously. So he is saying that just listen the product price update event. Okay, this event continuously he will listen and then asynchronously update the active cards. Architect will say that pricing service should remain the source of truth. Okay, card prices are estimated until checkout. So cart and this pricing both are different things. Okay, they will work independently. The pricing service is the only service responsible for calculating the final price. The shopping cart shows the estimated price. Okay, shopping cart will show the estimated price, but the source of truth will be from this pricing service. Okay, but the price is recalculated at checkout because discount, taxes, shipping charges, and product price may have changed. So for example, user add the laptop for the in the cart for about 50,000 price. Okay, 2 hours later the laptop price changes to 48,000, and coupon expires. So at checkout, the pricing service calculate the final payable price at 48,000 plus taxes minus discount. So now why? Because it will prevent inconsistent pricing across the service and then ensure customers are charged using the latest correct price. Okay, now follow-up 7 is related to payment integration. Okay, so how you will integrate the payment. So see, if user has added the software engineer will say that user has added item in a cart. Okay, it will go to payment service, and then if the payment is successful, then only he will create the order. Senior software engineer will say that use idempotency key to avoid duplicate payment caused by retries. Okay, so here he is talking about idempotency keys. And then architect will say that payment should be orchestrated using the saga workflow with compensation steps if downstream operations fail. Okay, if any downstream operation fails, so he will compensate, he will just trigger the compensate event like refund. Payment is one step in the checkout process. Okay, if any later step like inventory or order creation fails, the saga workflow automatically perform compensation steps or undo actions, okay, such as refunding the payment or releasing reserved inventory. Now, follow-up question 8 is cart extensibility, expiration, sorry, cart expiration, okay. So software engineer will say inactive carts should expire automatically after a configurable time. So you will just configure some time there. Now senior software engineer will say use Redis or TTL or scheduled cleanup jobs, okay. And architect will say that cart expiration events can trigger inventory release and abandoned cart notification. So one service cart expirations event will get triggered. Okay, now follow-up question 9 is undo remove item. So let's say user has removed one item, but he can undo it also. Okay, so how you will implement that logic? So software engineer will say keep recently removed item temporarily so user can restore them. Now senior software engineer will say that maintain a short-lived undo buffer using Redis. Okay, short-lived undo buffer, so using Redis. So in Redis, just keep that item for some time. And architect will say emit card update event. Okay, here again he is talking about emitting the event. Okay, undo operation remains consistent across devices, so all the services will listen this event. Now follow-up 10 is related to promotions. Okay, so software engineer will say that you can give some promotions like buy one get one, festival discount or category discount. Okay, senior software engineer will say implement promotions using strategy pattern. So new promotion type can be added without modifying existing code. He is talking about here strategy pattern. We have seen that strategy pattern, right? And like percentage, flat, buy one get one. So now architect will say promotion rules should be configurable and evaluated at the centralized promotion service. So rule engine he will create. Follow-up question 11 is related to thread safety. Now here we are talking about concurrency. So software engineer will say that if multiple requests update the card simultaneously, rest condition may occur. So solution would be either use the concurrent hash map or synchronization where needed. Okay, now senior software engineer will talk about some logs here. So like you can use optimistic log or distributed log. Okay, so optimistic logging means use a version number to detect if someone else updated the same data before you save it. And distributed logging means allow only one server or service update the same data at a time. Now let's see the example of optimistic logging here. So assume conflicts are rare. Okay, every record has a version number. Before saving the application, check if the version is still same. If another user has already updated it, the update is rejected and the user must try again. So for example, initially let's say product was so one product was there, so stock is 10 and version number is 5. Now two users read the product at the same time. Okay, so user A will read that stock is 10 and version number is 5. User B will also read it, so stock 10 version number 5. Okay, now user A update the stock, so stock will become 9 because he has taken one. Okay, and version will become 6, version number becomes 6. And now at the same time user B also tries. Okay, so he save using version number 5. So he will say no, version has updated to 6, why are you saving it with the older version, right? So he will reject its request. Database says version mismatch and someone else has already updated the record. So user B must read the latest data, version equal to 6, and then again he will try again. Okay, so this is the optimistic logging. Why use it? So prevent two server from accidentally overriding each other's changes, and no lock are held when user are reading the data. So it's a fast and works well when conflict are uncommon. So see, user A and user B were able to read the data only at the time of write data. We have we have applied that logic there. Okay, so it is faster. We are not holding any lock here, so that they have to wait, so it is faster. Now architect will say that optimistic concurrency with version number. Okay, here he is also saying the same thing. Let multiple user work simultaneously but reject update if the data was changed by someone else. And idempotent API, here also he will talk about that if some request is sent multiple times, the result remains the same without creating duplicate update. Okay, now minimum contention, so reduce situation where multiple user or service complete to update the same data. Now how he can achieve this thing? Okay, how he can achieve this minimum contention? Don't give chance to user, okay, to update the same data. That is the thing. So now see, first one is partition. Okay, shard the data. So one user have in one database, another user have data in another database, so just do update. Instead of storing everything on one place, split data across multiple server. Example, user A to M is stored in database 1, user N to Z is stored in database 2. So now update happens with different databases instead of competing for one. Reduce shared data. Okay, so avoid having one global counter that everyone update. Okay, so global counter, global stock counter, don't do that. What you need to do then, instead of that each product has its own stock record. Okay, now next is use optimistic locking. So here we saw that, okay, allow everyone to read freely and only detect conflict when saving. Example, two user added the same product, only one update succeeded and the other retries. Fourth one is queue update. Okay, here we are checking the ways how you can have the minimum contention. So instead of updating the database directly, send requests to queue like Kafka or RabbitMQ and process them one by one. So like 1000 orders are there, so it will go to Kafka, and then inventory service update stock sequentially. So there you use the queue also. Okay, and then cache, read heavy data. So if many users are only reading data, serve it from the Redis instead of hitting the database. Now follow up 12 is design pattern. Okay, so software engineer will say that pattern I would be using is builder, singleton and factory. Now builder pattern, where he will use builder pattern. Okay, he has said that he will use builder, factory and singleton, but where he will be using these patterns. So see, builder pattern when to use. So creating complex object with many optional field. Okay, whenever you need to create a complex object, we create their builder pattern, we build the object. Okay, with many optional fields. So for example, order, you have one order. Okay, new order you have created with some fields. Okay, now use a builder. So see, instead of giving each items, okay, separately, what you will do, new order builder you have created, then you will set user, you will set item, you will set coupon, you will set shipping address. Okay, and then dot build. So whatever is required, you just add that. Okay, and then whatever is not required, whichever is optional, just remove that and then build it. So this is easier to read, and then optional field can be skipped. Okay, and avoids constructor with many parameters. So instead of sending everything, okay, you will send here null if this one is not required, but don't do that. Okay, just use this builder pattern, build the object. Okay, now singleton pattern. So where you will use singleton, when to use, only one instance of the class should exist. Okay, so for example, a coupon config manager loads coupon configuration once. So like for example, you have load the coupon configuration. Okay, get instance, or get instance from pricing config. Okay, so why only one shared configuration object we are using here? Avoid loading configuration multiple times. In Spring Boot, many services are already singletons by default. Now third one is factory pattern. So when to use, so creating different objects based on input. Okay, for example, different coupon type, you have one coupon type, factory pattern is percentage. Okay, factory decide which object to return. So if type is percentage, then return this object. If flat, then return this. If buy one get one, then return this. Okay, so here you will use the factory pattern. So now shopping cart simply uses coupon.apply, and without knowing the implementation it received. Now senior software engineer will additional parameter would be strategy. Okay, he will again use few more design patterns like strategy, observer, command, and then template method. So why he is using strategy for coupons, for observer for notification, command for undo the item, okay, undo or remove the item, and template pattern for checkout flow. Architect will say that I would emphasize solid principle and domain driven design. Okay, patterns should solve real design problem rather than being applied unnecessarily. So if it is required only, then you apply those patterns. Okay, otherwise he will emphasize on solid principle and DDD. Okay, domain design driven. Now an architect focused on designing the system around business concepts like cart, order, product, payment. Okay, these are domains, and follow solid principle to keep the code easy to maintain. Design patterns like factory, builder, strategy, etc. are used only when they solve the real problem, not just because they are popular, right? So now follow-up 13 is unit testing. So software engineer will say that test cases, he will use test cases for add item, remove item, update item, empty card, and invalid coupon. Okay, senior software engineer will say that he will also add, so this one though he will use, and then he will also add concurrent update. Okay, he will check this thing in a testing, concurrent updates, payment failure, expired coupon, out of stock, and merge cart scenarios. Now principal software engineer here will say beyond unit test I would define comprehensive testing strategy. Okay, he is talking here about a strategy like unit test for business rules. You have created rule engine, right? So unit test for that, integration test for service interaction. Okay, and then contract test between microservices. So what is contract test? Ensure that two microservices agree on the format of their API request and response. If one service changes the API in a way that breaks out another service, the contract test fails before the change reaches production. Correct? What was expected, now you have changed that pattern format. So how it will work, right? So he will do that contract testing. Then apart from that, end-to-end checkout scenario, then load testing for peak shopping events. Okay, chaos testing for dependency failure, and security testing for payment and authentication, performance testing for large carts. Now follow-up question 14 is related to database schema. Okay, so software engineer will say that he will create one cart table, then he will create one cart item table, and then coupon table. Okay, so now cart and cart item is one to many, we can see that. Okay, and then cart and coupon, so this is dot dot dot. Okay, so like you can have or you cannot have the dependency there. So now senior software engineer will say I would normalize the schema. Okay, he will add indexes like on user ID, cart ID, and product ID, and use optimistic locking for the version column. Okay, now he's talking here about version column and then indexing. So principal software engineer will say that he will use data strategy. Okay, so like cart table, which will be the metadata, then cart item table. Okay, lines item you will have there, and then event table for the audit or for the history. Okay, then after that Redis for active carts, relational database for durability, and event streaming like Kafka for downstream consumers, and read replicas for reporting, partitioning, sharding for very large user bases. So yeah, that's it. Thank you.